Don't see. Man,
Yes, beta.
I just drank the paper but you didn't see.
Okay. You have already sent it, isn't it?
Yes, man, same.
No problem. Lesson 6, flame and combustion. We have already through lesson 5. I will be giving you the homework today. Uh, and this one, textual questions and the LQs of lesson 5. Lesson 4 you already have, right, beta? Hello, boys?
Yes,
Yeah. You have already got lesson 4 question answers?
yes,
Hello? Yes. So I will be giving you lesson 5. If you have written it down, then only you can write lesson 5. That is what I'm saying. So if you have not written it down, lesson 4, please finish it up because I'm going to send you lesson 5 PDF today. Okay, beta?
yes.
Good morning, all of you. Morning, beta.
Good morning, ma'am.
So we wished each other before recording. After recording also, we have to wish each other. Is this clear? Start reading. We start reading.
Introduction. We use different kinds of fuel, for various purposes at home, in industry, and for running automobiles. Name a few fuels used in trading and industry. What fuels are used for running automobiles? Your list will contain fuels like cow dung, wood,
मैम हमारा चैप्टर
fuel,
5
petrol,
बाकी है ना
diesel,
चैप्टर नंबर
compressed natural gas,
Just a
etc.
minute. Now tell me, when someone is reading better, don't say anything. Let
ओके
Sahil finish, then you could have asked me the question. Yes, tell me what is the question?
मैम हमारा चैप्टर नंबर 5 तो बाकी है
What?
5 चैप्टर
Unfinished?
5
Why is he asking me this question, beta? We have finished chapter number 5.
पीडीएफ में भेज दिया आपने
Oh, Baba. I have not. I said I will be sending it today. Please hear.
ओके
Please pay attention, beta.
मैं लेफ्ट हो गया था इसलिए नहीं पता था
Please pay attention. I will be sending it today because I am starting with lesson 6. Until as I finish lesson 5, how can I start give the PDF, beta? Okay? And I give the PDF of lesson 5 when both the section will finish. The girls still have to finish lesson number 5. Is this clear? So that's why I have not
Yes,
sent
ma'am.
you. So you both have to be together, then only I can send you PDF. Okay, let's start. I think have you finished, beta? Sahil? Going through?
Yes,
So we are using different fuel at home, industry, and for vehicles. Now, there are fuels which is used in trade. You know what is meaning of trade? By which you get money, that is foreign exchange, and industry, which we are using for automobiles. Now, whatever fuels we are using, if we list it, they will be cow dung, wood, coal, charcoal, petrol, diesel, CNG, etc. Is this clear? Now, if I ask you, what is charcoal? Can you explain?
the burned wood.
Huh? It's not the burnt wood, better. If you burn it, it will turn to ash.
No, ma'am.
There are two
Wood.
types of coal. Just a moment. There are two types of coal. One which is like rock. Yes. one which is like rock, and there's another coal which is very light. If you put it in water, it will float. Am I clear? Am I clear?
Yes.
Hello? That charcoal, just you said wood. Actually, it is made of wood. It's more of a circular, cylindrical shape. Charcoals are generally cylindrical in shape. Is this clear? Because they are made of wood, but they are fossil fuel. It is the carbon form of wood. It is a fossil fuel, but we are not burning it. It is a fossil. Is this clear? Sahil, did you understand?
Yes, understood.
Now, this is what you get in gas station, and this is the refinery, petroleum refinery. Read it. Please read.
And that's your turn. You read.
मेरी टर्न है।
So
Read.
among yourself, you take turns and start reading. Why are you pausing, giving a gap so much, beta? The recording is on. It does not look good. If one stops, it is not reading. The other one should take it up.
You are familiar with the burning of a candle. What is the difference between the burning of a candle and the burning of a fuel like coal? Maybe you were able to guess right. Candle burns with a flame, whereas coal does not. Let us study the chemical processes of burning and the types of flame produced during the processes.
It is process. It is not processes. We have seen how the candle burns, right? Now you burn a candle and you burn coal. What is the difference? Candle will have a flame. Candle will have a flame, whereas coal does not. Candle will have flame, where coal does not. Actually, what is happening? Why it is burning? What is happening? What is the chemistry? That we will do it later. Read better.
Combustible substances which burn in air to produce heat and light, are called combustible substances. Example wood, coal, charcoal, kerosene, petrol, diesel, liquefied petrol, petroleum gas, liquid petroleum gas, compressed natural gas, CNG, etc. Wood, coal, LPG, kerosene.
That is later. That we will show you. What does it look like? Now, whenever you are burning something, anything you burn, it has to be in presence of air, right, beta? If you remove air, if you remove oxygen, do you think can you burn any substance? Hello? I've asked you a question. Answer me.
What?
You did not hear what I asked you?
No,
I said, if I remove air, will you be able to burn any object?
no, no.
So what is a must? Air is a
Oxygen
must
is used to burn.
to burn. So it is helping in combustion, right, beta? It is helping in combustion. Now, any substance which burn, what does it produce, beta? It produces heat and light. You agree? It produces light and it produces heat. Do you agree or not? Whenever you burn anything. Now, these substances are called as combustible substances. What are the examples? Wood, coal, charcoal, kerosene, petrol, diesel, LPG, CNG, etc. You see how does it look like? Wood looks like this, logs of wood. Can you see this here? Then this is coal. Then this is LPG that we use it at home. And this is lamp, kerosene lamp. Got it? Hello?
Yes.
Yes. So these are the combustible substances. Now what is combustion? Sahil, you continue if no one wants to read. Let's not waste time.
Okay, ma'am. Okay. Combust, combustion, the
Combustion.
chemical combustion, the chemical process in which a substance reacts with oxygen to produce heat is called combustion. The substance which undergoes combustion is called a
Combustible.
combustible substance. It is also called a fuel. Sometimes light is also produced during combustion. Either it's a flame or a glow. Air is necessary for combustion.
Thank you. The chemical process. Only we are talking about the chemistry. So obviously, the substance which I am burning is reacting with the air or reacting with the oxygen in air, right, beta? In the air we have oxygen, and the substance that we are burning is reacting with the oxygen which is present in the air, and what it does produce? It produces heat. This process is called as combustion, right, beta? This is called as combustion. And the substance which burns or which is undergoing combustion is called as combustible substance or fuel. Is this clear? When you are burning it, along with heat, we get light as well, as that light is called as either flame or a glow. And we already know that in presence of air, the substance undergoes combustion. See this over here? We are seeing both the things. This is candle and this is the flame. You see the difference? Hello? You see the difference
Yes.
better? I will do this activity and learn about the flame. Not flame, sorry, the combustible substance and non-combustible substance.
Activity 1. Collect some materials like straw, matchstick, kerosene oil, paper, iron nails, stone pieces, glass, etc. Under the supervision of your teacher. Try to burn each of these materials one by one. Of combustion takes place. Mark the material combustible. Otherwise, mark it as non-combustible. Can you name some more substances which are combustible?
So, what are they saying? Take straw. What is the meaning of straw, beta? Can anyone tell me what is the meaning of straw? It's not that straw with which you are sipping your fruit juice. No, I'm not talking about the straw. Straw is under the hole inside, and then you take your juices, you sip your juices, or you suck your juices, right? I'm not talking this now. I'm talking about other straw. What is the straw called as? Can anyone give me the example?
मैम वो लकड़ी जैसी आती है straw.
कैसी आती है बेटा?
मैम it's like a stick.
Yes, yes, you're absolutely right. Dried grass along with the stem. Is this clear? Is this clear? Dried grass it is. Straw is dried grass.
Yes.
Then you have the matchsticks, kerosene oil, paper, iron nails, stone pieces, glass, etc. Then the activity is that you have to burn all these items. Now, which items will burn? Tell me. Straw will burn.
Sorry, no. Yes,
Straw
it
will
will
not
burn.
burn. It will
Straw
burn.
will burn,
Matchsticks.
plastic will burn,
Matchsticks.
kerosene oil will burn, paper will burn, and
That's it.
nothing else will burn.
What will burn? What will burn? That's all.
Fuel.
Only these will burn. Nothing else will burn. These are combustible substances. And iron nails, stone pieces, glass. Glass will melt. If you give it heat, glass will melt, but it will not burn. So these are non-combustible substances. The one which is underlined is combustible, and one which is circle, it is non-combustible substances. You can see over here the same thing. What we will write? Wood is combustible, paper is combustible,
Not
iron is non-combustible,
non-combustible, combustible,
okay?
non-combustible,
And the other one is, which is the downward straw. Straw is
combustible,
combustible.
combustible,
Yeah. Okay.
non-combustible,
Is this clear?
non-combustible. Yes,
Yeah. Is this clear, Beta? This you have in a book, so purposely I
yes.
took this. This is second
Fix
activity.
a lighted candle on a table. Put a glass chimney over the candle and rest it on a few wooden blocks in such a way that air can enter the chimney. Observe what happens to the flame. Now remove the blocks and let the chimney rest on the table. Again, observe the flame. Finally, put a glass plate over the chimney. Watch the flame again.
What they said that you put a lighted candle on a table, right, Beta? Take a candle, light it, put it on a table. Over the candle, put a chimney. Okay? Put a chimney over the candle and place it in such a way that it is on the wooden blocks and air is passing inside the chimney. Is this clear? Air can enter the chimney. You put it in that way. See what happens to the flame. Now what will you do? You remove those wooden blocks and chimney will be straight on the table. Observe the flame. Okay. Then third, over the chimney put a glass plate. So you have done three activities. What is that? First, you put the chimney on the candle on the in such a way that air is there's a passage of or entry of air in the chimney. That's the first activity. Second activity, put the chimney, but there is no air in the chimney. Is this clear? Is this clear? But the top of
Yes.
the chimney is open. Top of the chimney open. Open. Third, even block the top of the chimney. That will be third activity. Let's see what happens. What is written, better?
Activity 2. What happens in the three cases? Does the flame flicker off? Does it flicker and give smoke? Does it burn unaffected? Can you infer anything at all about the role played by air in the process of burning?
What are we trying to find out? The role of air in the process of burning. Is this clear? By this activity, what we are going to suggest, how important air is for the combustion process.
Observations. We find that for combustion, air is necessary. The candle burns freely in
Peter, there
case
is a
of
full stop.
yes.
Want to
The
continue? You have
candle
to stop.
burns freely in case of when air can enter the chimney from below. In case B, when air does not enter the chimney from below, the flame flickers and produces smoke. In case C, the flame finally goes off because the air is not available.
What you saw, that combustion requires air. Air is must for combustion. In the case A, what we see when the air is entering the chimney from below, there is no problem. Candle is burning nicely. Candle is producing flame nicely. In the case A, is this clear? Boys, boys, can you hear me?
Yes,
Yes,
ma'am.
yes, ma'am.
Yes, you understood this much? Now in the case B,
Yes, ma'am.
when we have stopped the entry of air from the bottom, that is, we have removed those wooden blocks and the entrance of air is stopped from the bottom. So what happens? The flame will flicker. What is going to flicker? That means it will not burn easily, but it is about to extinguish. And then it starts producing smoke because the top of the chimney is open. And in the case C, finally the flame goes off. Why? Because we have cut the entry of the air from the bottom as well as from the top. Is this clear? Is this clear, Peter?
Yes,
What you see over here? See, there are two wooden blocks. Right, Peter, can you see this? So, the air is entering from the bottom. Is this clear?
yes,
Hello? So, air is entering from the bottom.
yes,
All this is air. Air. So, you can see the flame. Right, Peter?
yeah,
In the case of B, the wooden block is gone. So, there is no wooden block. It is the air of the passage of air, the entry of air is removed from the bottom. So, what will come? The flame, the smoke will come. You understand? Not flame, but the smoke will come. In the third case, we have covered from the top as well. So totally removing the entry of air from the bottom as well as from the top. This will extinguish. It will go off. Is this clear to all of you?
Yes.
Yes? Have you understood nicely?
Yes.
Hello? We have done activity twos. Two activities we have done. Now tell me what is the first activity, Vita? What was the first activity? Sahil?
Read.
see, it is
No, no. What is the
combustible
first
or not.
activity? Yeah. It was combustible or non-combustible substance. So you have to make a list of combustible substances and non-combustible substances. Second, what is the second activity?
Second activity was to see that air is, uh,
Necessary. Air is necessary for
yes, necessary
combustion.
for burning.
For burning or for combustion. Use the word combustion with it.
Yes,
Not burning, we will use the word combustion. Right.
yes.
Now activity 3 we are doing. So this is how you will relate.
Place a,
Okay. So start with activity 3, Vita.
place a piece of burning wood or charcoal on an iron plate or tawa. Cover it with a glass jar or a tumbler or a transparent plastic jar. Observe what happens. Does the charcoal stop burning after some time? Can you think the reason why it stopped burning?
What are we doing? We are taking an iron plate or tawa and we'll put on the tawa a piece of burning wood or charcoal, right, beta? And then we will cover it with a glass jar or a tumbler. Because why we are taking glass? Because we want to see what is happening inside, or a transparent plastic jar. What will happen? They want to ask you whether the charcoal will stop burning, and if it will stop, why does it stop burning? You're getting the answers also in observation. Okay, that's why I've taken both activity as well as observation. So you've got everything ready. Yes, good. Please read.
Do these experiences tell you tell you that different substances catch fire at different temperature? The lowest temperature of which a substance catches fire is called the ignition temperature. We find that a combustible substance cannot catch fire or burn as long as its temperature is lower than its ignition temperature.
What does it suggest? That different substances catch fire at different times. For example, you take a piece of paper, right, beta? You take a piece of paper and you take wood. Which one will take long time to catch fire? Paper or wood?
Yes,
What is? Tell me which one will take more time to catch fire?
and what
What
was
will
the
take?
option? Wood and paper. Paper will burn fast.
I said will take more time. Please listen to my question properly.
Wood will take more time.
Yes. So that means the ignition temperature is high, and in case of paper, the ignition temperature is low, right, beta? Is this clear? So all the substances, the combustible substances have got different ignition temperature. And at that temperature only it will burn. And if you give a low temperature than the ignition temperature, then that combustible substance will not burn. Is this clear? Is this clear?
Yes.
Yes.
Now I'm giving you some extra information. The history of the mastic, how mastic came to existence. Hello, please read.
The history of the matchstick is very old. More than 5,000 years ago, small pieces of pine wood dipped in sulfur were used as matches. In ancient Egypt, the modern safety matches were developed only about 200 years ago. A mixture of antimony, trisulf- trisulfide,
Disulfide.
potassium chloride, and white phosphorus with some glue and starch which was applied on the head of the match, made of suitable wood when structured against a rough surface. White phosphorus got ignited due to the heat of friction.
Now you understood how the mastic came to be, how we are using mastic, what it is made up of. So mastic, very old. How did it start? 5,000 years ago. Pine wood. Pine wood, I hope you know pine trees. So these small pieces
Yes,
of pine wood were dipped in sulfur. And you know sulfur is explosive, right, beta? Sulfur is used in explosives, in crackers. Now they were used as matches in ancient Egypt, we are talking about. Now let's talk about the modern safety match. Just 200 years ago it was made. This match is a mixture of antimony, it's trisulfide type of chemical, potassium chloride and white phosphorus, and it's got some gum, that is starch, on the head of a match, so it remains together. Now this match is made up of a wood which can catch fire easily, and when you are rubbing it with a rough surface on the matchbox, uh, this white phosphorus which is in the head of the match gets ignited by because of the friction with the rough surface. And this is how we are using the match. matchsticks. Is this clear? Is this clear, beta?
Yes.
Start. Again, I'm telling you this is not in the book. I kept it purposely. Okay? You should know all these things. Say beta. Continue reading.
This started the combustion of the matches. However, white phosphorus proved to be dangerous both for the workers involved in the manufacturing of
Quiet.
matches and
Stop
for
it. What are you reading, beta? It is proved. Why are you rushing? Read properly. You're changing the meaning of the sentence.
proved to be dangerous both of the workers involved in the manufacturing of matches and for the users. These days, the head of the safety matches contain only antimony trisulfide and potassium
Trisulfide.
chloride. The rubbing surface as powder glass and a little red phosphorus, which is much less dangerous.
Now that's how we started using the match, burning of the match, so it is combustion. Now white phosphorus is very dangerous. Why? Because it catches fire very easily. In the manufacturing of matches, it was dangerous, and for the people who were using, it was dangerous. So white phosphorus was ruled out. Now these days, white phosphorus is not used, but the head of the safety match has antimony trisulfide and potassium chloride, but not white phosphorus. And the matchbox with which we are rubbing the matchstick has got powdered glass so that friction will remove and little red phosphorus. Instead of white phosphorus, we are having red phosphorus, which is not that lethal as white phosphorus. Is this clear? Is this clear?
Yes.
Not now.
Yes.
When the
Read better.
match is struck against the rubbing surface, some red phosphorus gets converted into white phosphorus. This immediately reacts with potassium chlorate in the matchstick head to produce enough heat to ignite antimony trisulfide and start
Trisulfide.
combustion.
How the phenomena is taking place? When you strike the match, when you're rubbing it with the matchbox on the side of the matchbox, the red phosphorus which is present on the side of the matchbox, it gets converted into white phosphorus. And when it starts getting converted to white phosphorus, immediately this white phosphorus reacts with potassium chloride in the matchstick. And that much of heat is developed so as to ignite antimony trisulfide. So one after another, this reaction is taking place in the head of the matchstick, and then it starts burning. Is this clear? What happens first when you are rubbing your match stick, that's the head of the matchstick, against the side of the matchbox, right, beta, which has got red phosphorus? So this red phosphorus gets converted into white phosphorus. And this white phosphorus immediately reacts with potassium chloride, which is present in the match head, right? Match head. And this reaction produces heat. So antimony trisulfide gets ignited and it's burst into flames. Is this clear? How the chain reaction takes place? By the rubbing of the
Yes.
match head with the side of the matchboxes. Now we come, what is ignition temperature? I think we have to stop beta. The time is up.
Okay,
Hello?
ma'am.
Okay, beta?
Yes. Bye. Have a nice day.
Bye.
Take care.
And tell others also to take part in reading better. You only read it out today. Tell others also to read.